question 14, and go through our reasonings and answer those questions. So quadrilateral ABCD has vertices A 2, 6, B 0, 0, C 6, 0, and D 8, 6. Prove quadrilateral ABCD is a parallelogram. So read the following proof for this problem carefully and then follow the instructions. So quadrilateral ABCD has vertices A 2, 6, B 0, 0, C 6, 0, and D 8, 6. That's given. Okay, so now I'm thinking, okay, well, what's my game plan to figure out what the blanks? And I'm going to go through and I'm going to read the statement, and since the blank is on the reason, I'm going to read the statement and then find the reason. So the midpoint of AC is found at 2 plus, and they use this formula. Well, the reason is because they use the midpoint formula. So I'm going to select blank 1, drag it to midpoint formula. Alright, so AC bisects BD and BD bisects AC. Blank 2. Okay, well then I'm thinking, well, they're talking about bisecting, so I'm going to look through and see if they have anything related to bisecting. So the first one is, if diagonals of quadrilateral bisect each other, then the quadrilateral is a parallelogram. Well, AC and BD are the diagonals, so it's not quite proving that they're parallel, but they are proving that, and then the other option is definition of segment bisector. And that is what I'm going with on 2, because they're not talking anything about parallelogram in statement 3. So that's why we're going for a definition of a segment bisector. And another thing that I could do is scroll up here, go to our key terms, and look for segment bisector, which they have bisect but not segment bisector. So the other thing I could do is type it into Google. Segment bisector definition in geometry. Say, and then a point, segment, line, or plane that divides a line segment into 2 equal parts. So those are some options for you to find out what the definition of a segment bisector is. It cuts it into 2 parts. Alright, which means that they found the midpoint. So quadrilateral ABCD is a parallelogram. So then we're reading, if diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Okay, well, the statement was talking about a parallelogram, and the step before was talking about bisecting it. So yes, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. And I'm going to read this statement right here. If the diagonals of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Well, that may be true, but since statement 3 was talking about bisecting, we were proving about using bisecting diagonals and not using diagonals that are congruent. So that's why I'm choosing that the diagonals of quadrilateral bisect each other versus the diagonals of a quadrilateral are congruent, is because statement 3 was using bisection. And then we're going to submit that for grading just to double check and make sure that we were right or made a mistake before we move on. So we were correct with question 14. And then question 13, quadrilateral ABCD has vertices at A -2, 3, B 0, -3, C 4, 1, and D 2, 7. Prove quadrilateral ABCD is a parallelogram. Okay, and you might be thinking, well, you incorrectly answered this already. I forgot to record myself the first time that I went through this workbook, so this is our second version of the workbook, and I went back through and I just incorrectly answered all of them so that I could go back through and step you through to the correct answer. So anyways, if you notice that, just ignore it because I purposely went back through and answered incorrectly because this is the second time I am video recording it. So let's jump back to this, and Hank wrote the following proof for this problem. Given that the vertices of A, B, C, D are at A -2, 3, B 0, -3, C 4, 1, and D 2, 7, it can be shown that the diagonals of the quadrilateral are AD and BC. Well, the first thing that I want to do is I'm looking to make sure that his proof is correct. And so I want to visualize what this quadrilateral looks like. So I'm going to roughly sketch it. So A is at -2, +3. So there's A. B is at 0, -3. C is at 4, 1. And D is at 2, 7. Okay, so there's our quadrilateral. And he says that the diagonals of the quadrilateral are AD and BC, which is incorrect because they're the side lengths of the quadrilateral. The diagonals of the quadrilateral go from one corner to the opposite corner. So the diagonals are actually AC and BD. So right there was one mistake. And then the point of AD is found, the midpoint of AD is found at, so let's check his work. So let's use the x coordinates for A and D. So the x coordinates were -2 + 2 divided by 2. Yep, that was correct. The y coordinates should be 3 and 7. Yes, that is correct. And then he reduced it down using the midpoint formula. Likewise, the midpoint of BC is found at, let's see if he used the correct x coordinates for BC. So 0 and 4, yes, divided by 2, and then the y coordinates would be -3 and 1. Yes, that was what they were. And then he reduced it down to 2, -1. Because the midpoint of AD and the midpoint of BC are not the same. Was that true? Yes, the coordinates for the midpoint were 0, 5, and these coordinates were 2, -1, so they're not the same. The diagonals do not bisect each other. Therefore, the quadrilateral is not a parallelogram. What mistake, if any, did Hank make in his proof? Hank misused the midpoint formula when he calculated the midpoint of BC. No, he used it correctly. So that's okay. Hank identified AD and BC as diagonals, but they are sides of the parallelogram. Yes, that was his mistake. So let's check. Great job. Let's move right along, and I will do, I'm trying to do as many proofs as possible because I find that those are the hardest ones. So we'll try question 12. Quadrilateral ABCD has vertices at A -4, 8, B 2, 6, C -1, 2, and D 5, 0. Prove that quadrilateral ABCD is a parallelogram. Okay, so in this lesson we've been talking a lot about if the diagonals bisect each other. So I'm going to keep that in the back of my mind. And when I read through this proof. So read the following proof for this problem carefully and then follow the instructions. So we have the statement quadrilateral ABCD has vertices at A -4, 8, B 2, 6, C -1, 2, and D 5, 0. That is given. That was the information given right here. And so that's just what it was restating. So M, the midpoint of BC, and the midpoint of BC has coordinates here. So what were they doing there? And N, the midpoint of AD. So there's our midpoint right there. And I know those are beautifully straight lines. So N and M have these coordinates. So the reason blank 1. Well, I'm looking right here and they use the midpoint formula in order to find those midpoints. So blank 1, I'm looking for midpoint formula. And then M equals N. If 2 points are share the same coordinates, then they are the same point. That is true. And then AD bisects, so AD, that diagonal, bisects BC, and BC bisects AD, and blank 2. So what is the reason for that? Why can I say that they bisect it? And that's the definition of a segment bisector. So I would go back to your keywords or go back through the concepts and look for the definition of the segment bisector or Google it. That is another option to look up. And so then quadrilateral ABCD is a parallelogram, blank 3. Alright, so what's the reason that we can say that they're a parallelogram? Well, let's look. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. That sounds like a pretty good reason. And the distance formula, no, we're not talking about or using the distance. Definition of a midpoint, no, we're not talking about a midpoint right now. And if the diagonals of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Well, that sounds pretty good too. So how am I going to decide between these two? And how I'm going to decide is I'm going to look at the previous step. It says AD bisects BC. So we were talking about the diagonals bisecting each other. And that's why I'm choosing the first one, is because it talks about if diagonals of quadrilateral bisect each other. We were not discussing the diagonals being congruent. We were using bisection. So let's check that answer before we move on. It says great job. Okay, so now question 11. Given that quadrilateral ABCD has vertices A, x1, y1, b, x2, y2, c, x3, y3, and d, x4, y4, prove that the quadrilateral ABCD is a parallelogram. Which statements about the coordinate proof for this problem are true? There is more than one correct answer choice. Select all correct answer choices. Okay, so in the back of my head I'm thinking, okay, well, what would I need to prove that quadrilateral is a parallelogram? And we just discussed one. It would need to have that the parallelogram has diagonals that bisect each other. So let's look for that. So to prove that both diagonals bisect each other, it's necessary to show that the midpoint of one diagonal divides it into segments that are congruent to the segments of the other divided diagonal. Okay, well, this one talks about bisecting, but I want to see if I can visualize what it is talking about. So say I have a diagonal. So some diagonal. And the midpoint of this diagonal, the midpoint of one diagonal divides it into segments. Okay, divides it into segments that are congruent to the segments of the other diagonal. So that is saying that this segment would have to be congruent to the diagonal of this segment. And this segment would have to be congruent to the diagonal, the second diagonal segment. Okay, well, that they don't necessarily have to be congruent to each other in order to be a parallelogram. They do for a square, but not a parallelogram. And that information about being a square was not, I'm not sure if it was provided specifically in this lesson. So we're going to count that one out because it's not necessarily true to show that it is a parallelogram. Okay, so to prove a diagonal bisects another diagonal, you must show that one diagonal passes through the midpoint of another diagonal. That is true. That was in our definition in the lesson. So to prove that both diagonals bisect each other, it's necessary to show that the midpoint of one diagonal is the same as the midpoint of the other diagonal. That is also true. They have to have the same midpoint in order to bisect each other. And then to prove that diagonals bisect another diagonal, you must show that the two diagonals have the same length. Well, I'm just visualizing a parallelogram that is short and long. So we can have parallelograms like this, and the diagonal bisects another, that we have to prove that they have the same length. That is to prove the diagonal that is also a true statement. So we'll see. Okay, submit for grading. Alright, some of the answers selected are incorrect. Try again to increase your score. Alright, and the reason why I was hesitant on this statement, to prove that diagonals bisect another diagonal, you must show that the two diagonals have the same lengths. That could be true, but that wasn't an option that was given in this lesson. So let's unselect that because that might be something I'm pulling in from my previous knowledge and not based on the knowledge that was given in this lesson, which is correct. So I would write down in my notes that in order to prove a quadrilateral is a parallelogram, I would write down, prove that the diagonals bisect another diagonal. You must show that one diagonal passes through the midpoint of another. And I would also include, to prove that both diagonals bisect each other, it's necessary to show that the midpoint of one diagonal is the same as the midpoint of the other diagonal. So I would write that down in my notes based off of the information given in this lesson. So there we have question 11. And question 10, given quadrilateral ABCD has vertices at A26, B68, and C12 and 54. Prove that quadrilateral ABCD is a parallelogram. Okay, well, obviously I just... Okay, so which plan for a proof for this problem will show that ABCD is a parallelogram? Well, we just discussed two plans in question 11. So diagonals bisecting another diagonal, we have to show that one diagonal passes through the midpoint of another. So let's see if we have something similar to that. So use the midpoint formula to find the midpoint of AD and BC. Okay, show that the midpoint for both segments is the same. Finally, use the theorem that states that if diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Alright, so that sounds, it's finding the midpoints of the diagonals and that they're the same, and then using our theorem that diagonals of a quadrilateral bisect each other. Let's read through this one. Use the midpoint formula to find the midpoint of AB and CD. Well, AB is a side and CD is a side, so that's not going to prove that that it's a parallelogram. So use distance formula to find the length of AD and the length of BC. Then show that these lengths are equal and thus the segments are congruent. Okay. Finally, use the theorem that states that if the diagonals of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay. That may be true, but was it given information in this lesson? And that is, I believe not. So I'm not selecting that one. And then find the midpoint of each side of the quadrilateral. Then use the distance formula to find the distance between each set of midpoints. Finally, use the theorem that states that if the midpoints of the sides of the quadrilateral are equidistant, then the quadrilateral is a parallelogram. Okay, well, we've been using midpoints to find that they bisect each other, so I'm not going to select that one. So let's check our work. It says great job. The midpoints show that both segments are the same and that if the diagonals bisect each other, then it is a parallelogram. Alright, so let's read question 9. And AB has endpoints at A 4, -8 and B -6, -2. What are the coordinates of the midpoint of AB? Alright, so one way that I remember how to find the midpoint is I remember it as we find the average of the x coordinates and we find the average of the y coordinates. So to find the midpoint x coordinates, I'm going to average the x coordinates. So we have 4 plus -6 divided by 2 because there's 2 points. So then we're going to have 4 plus -6, which is a -2, divided by 2, and that's going to equal a -1. And then, so that's our x coordinate for our midpoint, and the midpoint y coordinate, I remember just finding the average, which is you add up everything you have and you divide it by how many you have. So I'm going to add up all of the y coordinates, so -8 plus -2, and how many did I have? Well, I had 2 coordinates, so I'm going to divide it by 2, equals -8 plus -2 is a -10, divided by 2. -10 divided by 2 is -5. So then my midpoint's coordinates are going to be -1, that was our x coordinate, and -5, that is our y coordinate. So I'm going to look through here at -1, -5, and check our work. And like I said, I just remember the midpoint formula by averages, and because it's easier for me to remember, oh, when I average something, I just add up everything I have and I divide it by how many. So when you're finding the average of the x coordinates, You add up all of your x-coordinates and divide by how many. And then question 8 refers to the previous 2 questions, so that means I would have to jump here to question 6. And it's asking, what is the sum of the x-coordinates of the 2 endpoints? Okay, well, sum means addition. So, and the x-coordinates are 2 and -2. And then what is the sum of the y-coordinates of the 2 endpoints? Okay, well, sum is addition. So for the x-coordinates, I'm going to do 2 plus -2. That's going to equal 0. And the sum of the y-coordinates, sum is addition again. The y-coordinate is 3 and 7. So I'm going to do 3 plus 7, and that equals 10. And then it says enter your answers to the 2 questions in order separated by a comma. So this is how I would enter it. I would enter it as 0, 10. And then we're going to submit question 6. All right, and great job. There we have it. So there's your examples for workbook 5. And if you have more questions, please email me, fill out the help form, or attend the live office hours.